Okay, so we just established in this triangle what the sine, cosine, and tangent ratios are. Turns out that the sine ratio isn't going to help us very much because it's variable over variable, and like who cares about that? Like I can't really help that. I can get a value for this in the calculator. We'll find out pretty soon, but it tells me what the ratio is as to y over x. That's not going to help. Check out this. I got one variable in here, so that's great. Cosine 42 equals 6 over x. Well, what's the cosine of 42? All right, let's go to the calculator. If I type in cosine of 42, all right, so how do I figure out what the cosine of 42 is? Well, first of all, I got to go into this little thing called trig right here. If I hit that, I get the little trig menu. I can type in cosine. I can type in 42. And I get the cosine of 42 is the cosine of 42. Well, thank you very much. That's kind of like some of the stuff up here where I get exact values, and I'm not really helped by that because it just gives me the same thing again. If I went cosine 42 again and asked for that as an approximate value, well, that's kind of helpful. Did everybody get cosine 42 equals 0.74 blah blah blah? You may not have. Okay, if you didn't, check this out. Notice what I did there. I press Doc. In Documents, I go to Settings and Status. I go to Document Settings. And I see if my angles were set to degrees. What we just entered here was 42 degrees. This calculator will accept angles entered in lots of different formats. And what we want right now are degrees. If you did cosine 42 radians, it wouldn't turn out the same. If you did cosine 42, whatever else they have, it may not turn out the same. So we want the cosine of 42 degrees. And the cosine of 42 degrees is 0.74. So theoretically what's going on over here is we have a 0.74 over here that equals 6 over x. You know what though? Let's not do it that way. Let's not do it because it's going to be easier to do it. It's going to be more accurate to go to the calculator at the end. Let's solve this for x first, and then we'll deal with that 0.74 whatever it is as a decimal later. Let's try to get this to be just x equals, and then we'll have this mess, and we'll do it all at once. All right, so if I'm trying to get x by itself, this is kind of a mess because x is underneath the fraction here. So to get x by itself, I'm going to need more room. Let's go over here. Let's multiply both sides of this fraction, or sorry, both sides of this equation by x. So I would get x times the cosine of 42. And I think of cosine of 42 as kind of one number, like this thing in the box. That's okay. And that's going to equal 6 if I multiply both sides by x. Then to get x by itself, I would divide both sides by the cosine of 42. So this is what I was talking about. Let's get it this way. X equals 6 divided by the cosine of 42. All right, let's go back to the calculator. 6 divided by the cosine of 42. And I want a decimal for that because it asks for decimals in the problem. And I get 8.07. Okay. Whoa, what happened there? All right, so x here equals 8.07. That's good because I wanted x to be bigger than 6. So great. All right, let's try the thing for tangent. Tangent of 42 is supposed to equal y over 6. Well, again, let's get y by itself. I could get y by itself if I multiply both sides by 6. And think of tangent 42 as a number. Tangent 42 is a number, and that's supposed to equal y. 6 times the tangent of 42, and I'll get a decimal for that. So 6 times the tangent of 42, and that the same way. 6 times trig tangent 42, and I want an approximate answer, and I get 5.40. 5.40. Now, did that turn out to all my expectations here? Yeah, I kind of expected x to be bigger than 6, and I kind of expected y to be less than 6. Great. That all worked out nicely. Okay. Find sine of A, find measure angle A, and find measure angle B. Okay. So it looks like we're concerned with angle A when we find the sine of A and when we find measure of angle A. All right, the sine of angle A we already know from SOHCAHTOA back here a little bit, sine equals opposite, remember SOHCAHTOA, sine equals opposite over hypotenuse. So opposite here, what's opposite to A? Okay, opposite to A, oh, that's 24. And what's the hypotenuse? Don't think about angle A anymore, just hypotenuse is hypotenuse, that's 25. I guess I'm kind of done here. Find sine of A, I found sine of A, it's 24 over 25. Correct it 2 decimal places, well, okay, if you really want a decimal, we could change 24 over 25 into a decimal, but it's not really a job for a trig function. This is 24 over 25. That's 0.96. If you must have that as a decimal, then great, it's 0.96. What's the measure of angle A? Well, I know the sine of A is 0.96. There's a way to figure out in our calculator, if we know that the sine of A is 0.96, there's a way to actually figure out the measure of angle A. In other words, a way to cancel this idea of finding the sine of the angle to actually figure out what the angle is. And luckily enough for us, it is in the same menu. Underneath where we have sine, cosine, tangent, we have these little functions down here, which have a little sine with a little symbol by it, cosine with a little symbol, tangent with a little symbol, and I notice they're right underneath. That's kind of nice. This is what's called the inverse. If I take the inverse sine of 0.96, it's almost like when I go control square root for the square. Notice how square and square root are on the same button. This is like sine and inverse sine kind of on the same button. And again, I'm going to do approximate answer. And this does exactly what we need it to here. This tells us if we know what the sine is, it tells us what the angle size is in degrees, 73.74. So if we know what a trig function comes out to be, it will tell us what the angle should actually be. So this is 73 degrees. Great. Find measure of angle B. You know what? Look at this triangle. I have a right angle. I have a 73-degree angle. I know that the whole triangle adds up to 180. Don't forget that rule. That's a thing. So I know that these 3 things have to add to 180. I know that these 2 angles, angle A and angle B, have to add up to 90. So I could just do 90 minus that number, and I'll get, whoa, that's not what I want. Let's try that again. 90 minus that number, but I want this approximately. 90 minus that number is 16.26. Awesome. So that means the measure angle B must be 16.26. Okay. Okay, find the cosine of B and the measure angle B. Okay, same kind of problem. Find the cosine of B. The cosine of B, all right, cosine was, in my SOHCAHTOA, cosine was adjacent over hypotenuse. We're talking about angle B, adjacent over hypotenuse. Oh, hey, wait a minute. If this is 12 and this is 6, I know what kind of triangle this is. Anyway, I'm supposed to know what this side is if I want adjacent over hypotenuse. I want this side over 12. But just a second. If this is 12 and this is 6, does that look familiar? Before did we see this? Where if that's 12, that's 6. You know what? If I imagine another triangle here, that would, or kind of reflect this triangle over here, that would have had to have been part of an equilateral triangle. This is going to have to be a 30, 60, 90 triangle. This is 6 times the square root of 3. So, if this is adjacent over hypotenuse, this is 6 times the square root of 3 over. Now, I also could have got this by Pythagorean theorem. So if you didn't see this, don't worry about it. You would have got this with Pythagorean theorem. All right, so cosine of B is adjacent over hypotenuse over 12. And I can figure this out in the calculator. 6 root 3 over 12. Okay, 6 times the square root of 3 over 12, and it's about decimal places, so let me do that. 6 root 3 over 12 is 0.866, so am I here? No, I'm here. This is 0.867. And find the measure of angle B. Well, if the cosine of B, I should probably do that as squigglies. If the cosine, the cosine of B is that, then if I want to find B, I have to take the inverse cosine of that. So let's go trig inverse cosine of that answer. And approximately, that gives me exactly 30 degrees. You know what? I'm not surprised by that. I kind of knew angle B was 30 degrees if this is a 30, 60, 90 triangle, but the calculator just verified that for me. Okay. Tangent, we haven't really talked about tangent much. Tangent over here was opposite over adjacent. If you're in coordinates, tangent, all right, so this is some angle here. If we were in coordinates here, this would be the opposite side to that angle x. This would be the adjacent side to that angle x. Tangent, remember, was, if you look at SOHCAHTOA, tangent is opposite over adjacent. Opposite over adjacent here, notice that would be, if we were in coordinates and we were looking at this way, that would actually be the same thing as rise over run. This we used to call rise, this used to be called run. So tangent, if you turn the triangle so that it's sitting on one of the sides of the right angle, then really what we're talking about for tangent is the same thing as slope, which should make you feel a little bit better. Anyway, let's do this problem. Gives the rise over run. If we know the slope, we can use the reverse of the tangent ratio to find the angle. Okay, great. So it's a way to, tangent is kind of a way to translate between slopes and angles. We've never really had that before. All right, we wish to find the angle, but we know that this is 8%. So we know that this car is driving up in such a way that the rise is 8% of the run. Well, it doesn't really say what any of the measurements are. We just know that what's ever going on here, the rise, sort of the inclination, if the car was driving flat, the inclination would be sort of 0, like there's a 0% rise, it's going this way. But if it's starting to go up at all, there's a percent rise that's bigger than that. So it's got an 8% rise. So one way to think about that is it's going up 8 feet this way for every 100 feet it's going that way. It could be any triangle similar to that. It would still be considered an 8% rise. So it rises 8% of its run every single sort of step of the way. And we're concerned about this angle here, which we're calling x. So in terms of x, this would be the opposite side. This would be the adjacent side. So the tangent, I would always write it out in terms of this first. Tangent of x equals opposite over adjacent, which is 0.08. So I didn't really need to write this out. I already knew the 8% was 8%. But in order to figure out x now, if I know what the tangent is and I need to find x, I need to do inverse tangent. So inverse tangent of 0.08 is going to be 4.57. So that angle is only 4.57 degrees. All right, this is the last slide, which is probably good news for you. I can't wait to see it in class because this seems like it's going to be kind of thick. All right, sketch a diagram of this. An isosceles triangle has a vertex angle of 40. So this is 40 degrees, and these sides are the same. And a base length of 18. And find the perimeter. Okay, so first thing I need to do is find the perimeter. Well, we can't really do trig unless we have right triangles. So if that's an isosceles triangle, I'm going to split it in half so I have right triangles. These are 9. I need to find this using trig. All right, that's 40 degrees. Each one of these is 20, 20, 20. I have these right triangles that have a 20 at the top, a 9 down here, and I'm concerned about that side. So the side I'm concerned about is the hypotenuse. The side I know about is called the opposite. Opposite and hypotenuse are related, if I look at SOHCAHTOA, are related as sine. So I know the sine of 20 is supposed to be opposite over hypotenuse, 9 over h. Let me solve that for h. And I skipped ahead because I'm running out of time. So I solved this equation for h, and I found out that it was 9 times the sine of 20. I did that on my calculator, and I found out that it was 3.08. So that's how long each one of these sides is. So I can find the perimeters, 3.08 plus 3.08 plus 18. And that's not too hard to add up. The last question is, so part B is about, well, what's the length of this side here? What's that altitude? Well, I know this angle is 20. I know this side is 9. What I'm looking at here, now I'm concerned with this side. This is the adjacent side to 20. This is opposite. I have opposite. I'm concerned with adjacent. What I care about now is tangent. Let's do that down here. And in that one, what I end up with is 9 divided by the tangent of 20, which turns out to be 24.73. All right, I'm out of time. I'll see you in class.